Melasty focused on two important points when designing milking machines. Milk flow increased to a maximum level by new and different designs on rubber liners and milking clusters and on hoses, which transfers the milk from clusters to buckets. High flow rate has been created by doing new designs on vacuum pump, vacuum tank and transfer elements. Why Melasty? A 5mm thickness metal blade is used to adapt the vacuum group on chassis to minimize the vibration. Which material is used for the wheel shaft, and it is routed through the chassis and strengthened by welding from rear and front. Vibrations during transportation is reduced and ease of use is provided by using high quality rubber wheel in 300mm diameter. During the manufacture of the chassis, the interconnection of the profiles made by pipe notching work. Thus, by increasing the welding surface, chassis became long-lasting. In general, this process is made in an easier way by crushing the end of the pipes. In that case, welding quality is decreasing and lifetime of chassis is shortened. Forming method is used in manufacture of vacuum tanks, and by creating a monolithic structure, the tank is strengthened against vacuum resistance. Other manufacturers produce the vacuum tanks by putting 3 sections together. As a result of R&D activities carried out by Melasty, it is detected the low flow rate is caused by using small diameter in vacuum tank inlet and outlet. A comfortable breathing is provided to the machine by increasing the vacuum tank inlet and outlet diameter size up to 32mm. Other manufacturers use diameter 17 and 21mm for vacuum tank inlet and outlet size. This causes a decrease in flow rate of the machine. Two drain outputs used for the evacuation of the water, milk and foreign materials accumulated in the vacuum tank over time. In that case, evacuations of substances are accelerated. Other manufacturers use only one output for the evacuation. Air tank hose connection developed by Melasty has 40mm outer and 30mm inner diameter. In that case, an increased airflow is provided. Other manufacturers' air tank hose connection has 25mm outer and 15mm inner diameter. That causes an insufficient airflow. Vacuum distributors designed by Melasty has 24mm output diameter, and airflow is stabilized by attaching the 3/4 brass butterfly ball valve to the vacuum distributor. Other manufacturers use T distributors with 18mm inner diameter, and airflow is reduced by attaching plastic valves with 12mm diameters. High vacuum capacity is aimed with production of Melasty milking machines, and studies carried out in this direction. A smooth surface has been created by honing inner surface of the vacuum pumps. Thus, friction is reduced, high vacuum obtained, long life provided in graphite pellets. Sound of the pump is minimized. The vacuum pump suction hole diameter is designed 30mm. Vacuum pump covers grinded, and loss of vacuum is prevented inside the pump. The width of the vacuum pump is designed to be 80mm. A larger surface is swept by graphite pellets, which produce vacuum, and high vacuum is obtained. Other manufacturers generally use non-honing surface, 24mm diameter for the suction hole, and 70mm vacuum pump width. This causes low vacuum, short life for the graphite pellets, high volume and temperature during operation. In that case, vacuum pump's efficiency and lifetime is decreased. The vacuum circulation is provided in an internal system in Melasty milking machines during the production of chassis. In that case, the vacuum line is isolated from a possible corrosion may will happen on the vacuum line in time. Vacuum created by the vacuum pump first goes to the vacuum tank, then goes to the vacuum distributors by connection hoses, and then finally goes to the pulsators and milking buckets. Vacuum never circulates in the chassis frame. The antenna shafts which holds cluster arms are made of rich material and strengthened by welding from top and bottom. Other machinery producers use 22 mm outside diameter and 14 mm internal diameter in milk hoses. Melasty milk hoses has 25 mm outside and 16 mm internal diameter. Thus, milk flow coming from cluster is accelerated. Melasty hose clamps are made of soft material as a result of R&D activities carried out by Melasty. Foam corruption is prevented for milk and pulse hose by using soft material clamp. Monolithic structure of the clamp also prevents hoses to set apart from each other after an overtime usage. Other milking machine manufacturers usually use 160cc round-shaped milking clusters. Milk coming from the breast is drowning in the cluster because of the small volume of the 160cc clusters and redirecting back to teats, and that causes the main reasons of the breast diseases on cows. 240cc oval-shaped cloths are used in Melasty milking machines. The turbulence is minimized because of the oval shape of the clusters. In general, the world standards for 240cc clusters are 13 mm diameter for rubber liner exit and 17 mm diameter for cluster main milk exit. But in Melasty clusters, the dimensions are increased to 17 mm diameter for rubber liner exit and 21 mm for cluster main milk exit. In this way, the milk flow is accelerated. Rubber liner outlet diameter with other manufacturers are 9 mm. Melasty has designed the rubber liner outlet diameters 15 mm. This wider connection helps milk to be transferred faster from breasts to clusters. That feature is important for milking highly efficient animals. Longliner IGA due to the design and structure of billows. Convenient folding is provided and vacuum loss is prevented during the attachment of clusters to teats. Provides ease of use. Lactic acid in the milk, hot or cold water used during the washing cycle, weather conditions, ozone in the environment, and repeated movements during milking causes the liners deformed, elongation before expected expiration period. And this causes a reduction of strain within the teat cup shell. On 3111 IGA liners, as a result of R&D carried out by Melasty, insertion part of liner has been upgraded to 2 stages to bring the performance level increased again by taking from stage level A to stage level B when the deformation occurs. The neurostimulation effect is created by the nipple and breast massage, causes the secretion of the hormone oxytocin. Oxytocin hormone starts to milking and facilitating milking through the bloodstream after stimulation of nipples. Secretion of the oxytocin hormone lasts for 5 to 7 minutes. Milking must be completed within this period. Diameters of rubber liner outlets, cluster inlets and outlets and hoses directing to milking buckets expanded during the design of Melasty milking machines. So minimum time has been taken for a maximum level of milk from the animal breasts. Please note that milking is a race against time, and you have 7 minutes in maximum. Now I ask again, why Melasty?